All right, today we are diving into something really different. It's a new AI architecture called HyDRA, and the big idea here is to stop treating language like a flat line of text. Instead, think of it as a living, dynamic system inside its own curved, expanding universe. So, to really get why this is such a big deal, you have to understand the core problem HyDRA is trying to solve. It's a fundamental mismatch. Language is hierarchical, right? It branches out exponentially. Words become phrases, phrases become sentences. Well, the flat, grid-like geometry we normally use in machine learning, what we call Euclidean space, it just doesn't have enough room for all that complexity. So here's how we're going to break this down. First, we'll dig into why we need a new geometry in the first place. Then, we'll look at the high-level anatomy of the model. After that, we'll dissect the key organs that keep the whole thing stable, see how it actually regulates itself, and then we'll put it all together at the end. Okay, so why can't our current models keep up? It's really a volume problem. Trying to represent a hierarchy, like language, in flat space is like trying to flatten a real bushy tree onto a single sheet of paper. You can't do it without all the branches overlapping and getting squashed. You just end up losing all those crucial subtle relationships between ideas. So how do we solve this? Well, HyDRA's answer is pretty radical. It moves language out of that flat world and into a totally new geometric habitat, hyperbolic space. And here's the key intuition, the real aha moment. In hyperbolic space, the amount of available room literally grows exponentially the further you move from the center. The shape perfectly matches the exponential branching of a tree, or of language. It's like we finally found the perfect container for the job. Now, this isn't just some neat mathematical trick. The argument is that this is the correct inductive bias for language. It naturally lets you organize concepts in a hierarchy with tons of space between them, even as they're buried deep down in the knowledge tree. But, and this is a huge but, this powerful new world comes at a price. Yeah, you get all this amazing capacity, but it's also incredibly unstable. Training a model in here is like trying to build a delicate machine in zero gravity, where all these strange new forces are pulling on it. If you get it wrong, the whole thing can just fly apart. So, how is this HyDRA organism actually built? Let's take a look at its core anatomy, because it wasn't just designed to process language. It was designed to survive in this new volatile environment. The way information flows is a totally self-regulating loop. Data comes in, it gets processed by these specialized layers, then the system actually measures its own health, its vital signs, and it feeds those measurements right back in to control its own dynamics for the next step. It's constantly watching itself and adjusting on the fly. Okay, now we're getting to the absolute heart of the design. To survive in this wild hyperbolic world, HyDRA basically evolved a set of specialized organs, and each one is designed to fight back against a specific, deadly instability. You could think of them as cures for diseases that only exist in this weird geometry. So the first disease is basically a greed problem. Because of the way the math in this space works, the model quickly figures out it can get a higher score just by pushing all of its word embeddings out to the infinite edge of this universe. And that's catastrophic, because it completely destroys all the meaningful structure it's learned. The solution is basically a containment field. Think of it like putting a fence around this entire expanding universe. Really common words like the or a are kept close to the center, and rarer words can explore a bit further out, but absolutely no token is allowed to escape to the boundary. And this is the brilliant part of the mechanism. The model is literally engineered to be blind to the temptation of infinite radius. It doesn't care how far a token is from the center. It only cares about the relative angles between different concepts. And that makes it immune to that self-destructive urge to just fly away. All right, next challenge. Binding. You need some kind of attractive force to link related ideas together. Like king and queen. But if that force is too strong, everything just collapses into a single, indistinguishable point. We call that phase collapse, and it's where all meaning gets completely lost. HyDRA's solution here is just so elegant. It's rhythmic. Every token is like a tiny oscillator, a tiny metronome. And the closer two tokens are in meaning, the more their rhythms start to synchronize. So you get this flexible, dynamic binding through a shared rhythm, not some rigid, static link that could cause a total collapse. And finally, the system has to maintain its structure. If you just leave it alone, the model might learn these bizarre, nonsensical loops, like a dog is a pet is an animal, and an animal is a dog. That completely breaks the whole hierarchical structure that we chose hyperbolic space for in the first place.
So this component acts like a gardener for the model's knowledge graph. It's constantly on the lookout for any of these cyclical connections, and it just prunes them away. This forces the model's entire knowledge base to maintain that clean, tree-like structure.
So here's the crucial point. These organs don't work in isolation. They're all connected by what you can think of as a nervous system. And its whole job is to achieve a dynamic balance, something called homeostasis. The system stays healthy because it's constantly sensing and reacting to its own internal state. It's really a beautiful, self-regulating machine. It uses its own internal state, its telemetry, to tweak its own parameters on the fly. If it senses it's getting too hot or unstable, it just automatically turns down that binding force to cool things down. It prevents these huge instabilities before they ever become catastrophic. And you can see the difference this makes. It's stark. An earlier version, V6, which had these imbalanced forces, well, it suffered a complete collapse. You can see its diversity score just plummeted. But with that closed-loop control system in place, version 7 stays stable, and it actually learns effectively.
So what's the big takeaway here? What does this all really add up to?
This is the key insight right here. You have these repulsive forces from the main learning objective that are pushing different concepts apart. And then you have these attractive forces from those HyDRA and oscillators pulling related concepts together. Training becomes all about finding the balance between them. So you end up with these 5 core forces all working together: repulsion, attraction, structure, containment, and tension. They're all pulling and pushing against each other to find a stable equilibrium. It feels less like traditional optimization and a lot more like you're tuning a complex physical system until it just finds its perfect point of balance. And this really leaves us with a fascinating final thought. Maybe what HyDRA is suggesting is a whole new way to think about intelligence itself. Maybe it's not about a series of calculations, but about a self-organizing system that's just trying to find its perfect, most stable shape inside the right kind of geometric universe.